Okay, hello everybody. We are here from Team Sticator and we are going to present a webinar on the topic HashiCorp Vault on OpenShift for secret management. So this is our topic and we are going to discuss about protecting sensitive data in containers and the advantages of using Vault on OpenShift. So our session is going to be divided into two parts. In the first 45 minutes, we are going to be talking about how we are going to use OpenShift and how we can protect our data and what are the advantages of using Vault on OpenShift. And in the last 10 minutes, there will be a question and answer session where you can ask whatever you want to ask from our panelists, which are Sir Rashid and Callum. They are going to be guiding you and introducing you to all the advantages and benefits of using Vault. We are just waiting for a couple of minutes so that more attendees can join us, and then we can move forward with our webinar. Just give us a few minutes and then we'll get started.
Hi guys, welcome. Rashid here. Callum, you with me? Hear me?
Yep, I'm here. Hello, everybody.
Hi everyone. So guys, I'm Rashid. I'm currently sitting in Stockholm with a lot of snow around me. And so I think Callum, how's on your side?
Yep, good. I'm Callum, sitting in the Czech Republic. We don't have so much snow, but it's a bit muddy and cold. Looking forward to summer.
Okay, good. Yeah, same here. So guys, welcome. So today's topic is going to be on HashiCorp Vault, like the open source version. And we're going to be sharing our experience of running HashiCorp Vault for secrets management. And let's start then. Quickly about, I can introduce myself, guys. I'm Rashid. Still, I love to write code when I get time. So I've been a developer originally. Still, I think I like to be called a developer, but I don't get time for doing it. But I've been doing Kubernetes for the last almost 6 years since Kubernetes was born, and been in love with it, and been working a lot around Kubernetes and the whole ecosystem, and been helping customers how to adopt this technology and how to take benefit out of this, because I call it a lovable beast, and with a lot of power inside it. And over to you, Callum.
Yep, I'm Callum. I'm originally from New Zealand, but I sit in the Czech Republic and have been working with Rashid and Sticator for a number of years now. Labeled as a principal software engineer, but I consider myself more of a platform engineer. Have a lot of experience with cloud and DevOps type stuff over the years, and which we sort of put into practice with our platform engineering that we do as a sort of core competence within Sticator. Pleased to be here. Thanks.
Yeah. Good. So here's kind of our agenda for today. Callum, you want to go through it?
Yep. So we'll go a little bit into like whether you actually need a secrets management platform and why you need a secrets management platform. Understanding the needs of the business and of the infrastructure and where it makes sense to introduce something such as Vault. And then we'll go a little bit into so I guess some lessons of how or the way that we manage Vault on our platform. We don't have a ton of time, so we could speak for days about this topic, I think, but we'll try and cram as much as we can into short time that we have, and hopefully leave you with some additional reading that can be done at your own pace. And then we'll go a little bit more into, once you actually have a secrets management platform running, how to actually interact with it and consume secrets, in a bit of a demo on how we've set things up and instruct our customers basically on how to interact with Vault.
Awesome. Going on, so day 0 actually. So what are we going to talk about in this particular section is that what is actually a secret, like starting with the basics, how to actually define a secret, and then talking about, okay, why do secrets matter, like why are secrets so important, why do we talk about them, are they really important? Then the next thing is, like, if you have to look for a secrets management solution, what are the core principles that you have to look for? That, okay, we need a secrets management solution then, but what are the principles we should be following, when we are trying to evaluate the different options that are available in the market, because you have many. And then, like, we'll talk about some of the options that we have kind of experience with, and like how they work. And then we will have a brief introduction of what is HashiCorp Vault and what features does it have. So I think we all understand, everyone who's here actually, that we have this common question, because now we live in a world of microservices where we're doing more and more applications, trying to build as smaller applications. I don't know if it's good or bad, but yeah, we are building a lot of microservices now these days. Which means that secrets are now even much more distributed as compared to before, because previously we were just doing monolithic applications, but now we build a lot of microservices. So now we have to make sure, okay, in this application needs a secret, how do they get secrets? And we actually try to answer this question, okay, where do we store the secrets? That's the first questions that pops up in our mind actually. And then the second questions that pops up is, how do we manage the secrets? Like, okay, now the secrets are stored somewhere, but how do we manage them? How do we rotate them? How do we life cycle them, and everything around that? And then the last and the key important thing is, okay, if the secrets are stored somewhere, how do the applications or servers actually access those secrets? So these are like the common questions that everyone who's doing application development these days have to kind of figure out the answer for these questions. So starting with the basic definition of what is a secret, so I think secret is basically a credential, anything that grants you an access to a system, which could be username and passwords, it could be TLS certificates, could be API tokens, or database credentials. And I think these are very common, and every day we are doing development, we actually are using these kind of secrets, like we are using somewhere in our applications. So I mean, we can say they are like secrets we have to be careful about. Then here are like some examples of to think about, okay, is this a secret, or is just not a secret but sensitive information? So if you look at database credentials, SSL certificates, encryption keys, API keys, all of those are secrets. But then other things like phone numbers, email addresses, I mean, most probably it could depend on your context, but I think they are actually more like not secrets, but more like a sensitive information. So the first thing you have to start with, okay, what information is actually a secret, that we have in our system, and so you have a proper understanding, So I think having a proper understanding of your credentials that you are using in your applications is the first thing to start with, Okay, what credentials do we have in our whole environment, and how do we handle them? Then the question pops up, okay, are secrets really important? Like, do they really matter? And yes, I think they matter a lot, because you can see that data breaches are now routine occurrences that happens, and which can result in lawsuits or fines. And of course, if victims whose personal information is stolen, they can have what we call identity theft or privacy loss. And then, of course, if we can secure our secrets properly or limit, then we can limit these what we call the data breaches. So yeah, secrets do matter. And this is a very common thing, I think Callum, maybe you want to also add here, like the secret sprawl, like the questions that I think every team has to answer. Like now we are doing a lot of small teams that manage a couple of applications, that, and we have to answer these questions, right, Callum? Like
yeah, like it's very common to have developers with configuration files on their local machines that have a bunch of secrets, even for accessing production, or having secrets with the nature of platform and infrastructure these days, where services and systems are distributed across like multiple cloud platforms or hybrid on-premise and everything, and having secrets distributed all through your infrastructure and on different servers, and quite easily losing track of what's where. And if there is, for example, a credential that's leaked or breached, actually trying to figure out where that thing is used and where it's saved, and trying to track and trace these pieces of data through your infrastructure can be quite a big task. So trying to eliminate this concept of secret sprawl can be an important step.
Exactly. And I think like these are some of the common ways that we have secrets have seen stored at different organizations or customers we have been involved with. Might be, still it is true. We have seen passwords and PGP keys being sent through email. Might you laugh? Okay, is it really? Yes, still there are. We have seen cases where they are put in source code. It looks old, but still they are there. They have been put in configuration.
Like it's not always intentionally put in source code, but you often find even GitHub themselves recently committed their private keys to a public GitHub repository. So it happens, and to try and eliminate that or limit the chances of that happening should be.
Yeah, exactly. And then I think it's like you can also store them in some like Amazon S3 buckets, and maybe end up in your source code. I think we see, and then often you might be storing them in plain text on your laptop, or maybe on a sticky note somewhere. Okay, this is the password. Yeah, on the server you have sticky note. This is how you log in to the server. On top of like on the server you put, okay, here's the username and the password. So they're like a common ways where secrets are stored, and there might be many more that you guys have experience with. And then what's wrong with this? Like of course, I mean, we don't know, right? Like who really has access to all of these things? I mean, we don't have answer. We don't know that, right? And then we don't know who has actually accessed these things. Like, okay, who has access to those things and who has accessed them? We don't know actually. We have no visibility. And I mean, are these secrets still only in this place? Do we know that the secret I have here on my notepad, is it only here, or someone has taken a screenshot of it and it's on the phone as well, and it's everywhere? So, and like, can we really rotate the credentials, or do we rotate the credentials? So I think all of those things are like, okay, if you do those ways of storing the secrets, then we have all of these issues with that. And then the question comes, are like our secrets safe? I mean, you have to look into that. Like, what if an application logs it? I mean, this is a common pattern we have seen. Like, again, this is by mistake, but sometimes we have seen applications are logging, like by mistake, we log the secrets into the logs, but then then your logging solution picks them up and send them for long-term storage. So that means then your secret is now in your long-term storage for a couple of years in plain format. So unless you don't rotate the secret, your secret is almost like available out there. Anyone can go and creep the logs and say, take a look. I mean, what if you put the log, get logged into stack trace? That does happen as well. I mean, and then what if someone is debugging the memory problem in their app and they see the secret in the memory dump? And what if it ends up in your monitoring report? So I think there are like different ways where we have to see, okay, secret is not only in one place, it could end up in other places. So we have to look and think thoroughly, okay, is it really a static secret that will stay static, but it might change over time. So it's important to keep an eye on that, okay, how do we rotate our credentials, because that's
But I think the point here is that these things happen, and a secret management platform doesn't necessarily stop these things from happening. But if you don't have good secrets management and these things do happen, it's how to recover from that state, because not being able to rotate these credentials quickly and easily, or knowing the source of these credentials so you can quickly rotate them, is the problem I think that's been highlighted here.
Exactly, yeah. And I think this is the truth about, like the longer a secret lives, the less we know. So I think this is a very important lesson, I think, that you have to remember, that the longer it lives, the less we know about the secret, because we don't know who knows about this secret. So secret rotation, I think, is one of the key principles to be kept in mind for secrets management solutions. So I think talking about the core principles, we won't have much time left, so I might be rushing a bit, but I think one of the key principles is the minimum privileges, like who has access. That has to be least privileges. You can control that. There should be possibility to set expiry on the secrets so that you can rotate them. Another important thing is about the weakest link. So it's as secure as the weakest link in your access control mechanism. So you have to be very careful about that. And it should be easier to do the right thing than the wrong thing. So I think if this is a principle, so if you are choosing a tool that allows you to do the right thing easier than the wrong thing, then it's also very important, So it shouldn't be that people can do a wrong thing easily, then they usually try to, we try to go that way actually. And then of course the secret system must be highly available. So then I think this is one important thing. Do not store the secrets in your source control. It can happen sometimes, but be careful with that. And of course, changing a secret shouldn't require you a full deployment. We will give you a demo, of course, where you don't have to do a full deployment, but a change of secret will restore the application. Okay, so what are the different options that are kind of available in the market, in terms of secrets management? We have something called, we're talking more about from Kubernetes perspective. There might be other things out there, but these are the ones that we have experimented or worked with in terms of Kubernetes. So one is called sealed secrets. It's not like a complete secrets management solution. It's just like a way for you to store your secrets and utilize them in your Kubernetes cluster.
In your source control.
Yeah, in your
source code.
Yeah,
basically.
in your source code, but sealed. Yeah, but sealed, but we didn't have much positive experience with the sealed secrets. It's a pain to work with, but yeah, it's a start, But then if you come to like HashiCorp Vault, yeah, this is like a more like a full-blown secrets management system with tons of options. Then you might be using the cloud secrets manager that are available out there that you can use. And then Doppler is another one. And then I'm pretty sure there are many more other that are options available, like CyberArk and like Keeper, 1Password, like a lot of options are there. So you can go and choose. But then I think if you just make sure that you have set your requirements properly, and you have set your, okay, what we're really after and what features we need, then maybe you can choose the right, I would say, option from here. So we need a system that supports squad operations, provides an audit trail, protects secrets at every stage of this life cycle, permits access control to be defined by policy. We want everything as code, is highly available, and has flexibility and authentication mechanisms. So we need a system that kind of offer us these things, like, okay, we can do stuff programmatically without a trail and as code. And then we enter into the vault, and basically vault, I will just talk about the vault features. And primarily, if you look at vault, it does have those things like built in. Like, it's a secure secret storage solution, both in transit and also when it's at rest. It has a very solid auditing mechanism. You can have configured different auditing backends, and basically Vault prefers safety over availability. So that, I think, it's a good core principle they have built Vault on. And it has a very powerful, rich ACLs, access control list, which means you can control access of people who want to get access to Vault to do stuff. So it's pretty powerful in that sense, very rich. Being rich also means you have lots of options to configure. So you have to figure out what to do and how to do it. It supports lots of different authentication methods, right, Callum? That's what you like about Vault. Like,
yeah. So it's one of the features over, for example, when we compare to the cloud platform or the cloud providers' secrets platforms such as AWS Secrets Manager or Azure Key Vault. Our platform is hybrid multi-cloud, using like a dedicated secrets management engine or managed one, does limit you quite heavily when it comes to integrating with that thing, but the way Vault handles, which we'll go into a little bit later on, but there's just such a wealth of options available with Vault.
Yeah. And then it is a very nice feature of leasing, renewal, and revocation of secrets. And it does also have support for dynamic secrets for your Postgres, for your MongoDB, your DynamoDB, and anything. So that feature I really also like about Vault, like you can have dynamic secrets. So then only the application that is consuming the secret to connect with the application knows the secret. So it's pretty powerful. Okay, good. So that's it. Now we have a very small poll here, like that we'd like you guys to answer. And maybe Sania, you can show the poll. So I think it's going to just take you 1 second or a minute. It's like 30 seconds you have. So please
Pick one.
Pick one. Not hard at all. Yeah. So let's see what people pick up. I did the same poll on LinkedIn actually, Callum, and I got like 51 responses, and to my surprise, HashiCorp Vault was the highest in the, like, people have responded, as they have selected, it's one of the options. Okay, good. So Sonia will, yeah, okay, good. Now do you see my screen again, Callum?
Now I do, yeah.
You do, awesome, good.
Yeah.
So then I think we will move on to the section 2 now, Callum, over to you. I can be your guy who's gonna be.
Yeah, so yeah, let's just flip through. So when we talk about day one, we're talking about now that we've decided to build Vault secrets management platform, then what sort of concepts do you need to think about and deal with? And based on a little bit about how we do things, there's typically in platform engineering, there's many different ways of achieving something. So this is quite opinionated, but it's the way that we've found works best for the way that we work. So a few of the concepts that we'll just really briefly touch on is deployment, the concept of unsealing Vault, how to do storage for the Vault backend, the authentication and authorization concepts, some brief points on security when it comes to Vault and backup and recovery of your Vault. Push through, Rashid. So like, how do we deploy Vault on Kubernetes? So HashiCorp maintain and provide quite a robust Helm chart. If you're not familiar with Helm, I'm not going to go into a lot of details on some of the technical stuff because obviously we don't have time, but hopefully it's things that you're familiar with or at least can do some research on. But they provide a very good Helm chart, which actually has good support for both vanilla Kubernetes as well as OpenShift. We build our platform on top of OpenShift, so having the OpenShift support out of the box is quite nice. But the way we tend to do things, or a concept that we follow quite strictly, is this thing we call GitOps, where everything in the platform has to be basically be able to be traced back to a commit. And the Helm chart out of the box, if you're at all familiar with it, it'll bring Vault up, but then there are some manual steps that are needed to sort of complete the deployment, to initialize the Vault and to unseal the Vault and to do certain things. And so what we do is we put a wrapper around this Helm chart and extend it with some of this additional functionality so that we have the end-to-end automation, basically, so that when Vault is deployed to a cluster, that it'll come up, it'll automatically initialize itself. It will have like the first authentication method bootstrapped so that we can then pass on to other tooling to complete the internal configurations of Vault, which is quite there's quite a lot going on inside Vault. We extend it with also a cron job to run some backups, like configurable schedule to get your data backed up, and also to, for example, to generate some certificates that Vault can use for TLS and into node communication and things. And if you've got something like Cert Manager already running in your infrastructure, then automatically generating certificates for Vault is pretty easy as well. And these sort of additional bits and pieces that typically, if you follow through the Vault documentation, then once the Vault's deployed, then these things are performed via the CLI from the operator's workstation. But trying to strive for everything as code, we prefer to wrap the chart with additional automation, basically. Can you go to the next slide? So then, when talking about Vault or reading documentation about Vault, this topic of sealing or unsealing Vault will come up. And basically, when Vault starts, it has its storage encrypted, but there is no master key or keys to basically to decrypt that storage. So you need to initialize Vault and unseal it to be able to use it. And in the past, or when running Vault on virtual machines or servers, well, basically there's two concepts of unsealing. There's the manual unseal, and then there's this auto unsealing. And the manual unsealing, so every time Vault starts, you need to unseal it. And to do the manual unseal is pretty fine when it's on a static infrastructure where you have full control over when your servers will restart, or at least more control over when your servers will restart. And punching in the unsealing keys during maintenance is not a big issue. But when running something like, well, running Vault on something like Kubernetes, where you have really little or no say in when your Vault nodes might restart, it was important, and it was a bit of a game changer when HashiCorp released this feature of this auto unseal, where we're able to offload that key management in the unsealing procedure basically onto a trusted third-party key management system. So we do piggyback on Azure, on AWS KMS, for example, where the Vault has a KMS key or access to a KMS key. So when the pods restart or when Vault is deployed, that it can automatically unseal itself, which will save some late night calls for the operations team having to unseal Vault manually. If you're running multiple Vault instances, maybe you have like a hub and spoke topology, for example, then it's also possible to do something called transit unseal, where one Vault instance will use another Vault instance to do this unsealing mechanism, which if you're fully on-premise, for example, or not able to utilize these cloud-based KMS solutions, then maybe you'll have like one Vault instance running on a virtual machine with a manual unseal procedure, and then all of your Kubernetes clusters can have Vault instances doing auto unseal via that single hub Vault. There's options out there, but it's quite important that you, well, in our opinion at least, it's quite important that you utilize this auto unsealing when it comes to running Vault on Kubernetes or OpenShift. Yep. So then the concept of storage. So there's a few different ways to do storage, and storage is quite important when it comes to Vault when you're trying to store data securely in an encrypted way. You want your Vault to be highly available if possible, but so it's quite a new feature that Vault has now, but basically there's something called the Raft protocol, which is a protocol that I believe HashiCorp actually developed. That's a consensus algorithm that Vault can use to basically replicate its data between its own nodes, which means that we can now just basically use simple PVCs or simple persistent volumes and native Kubernetes storage to run Vault in a highly available way without having to introduce something like Consul or some other complexity to basically manage a robust storage backend. So Vault can basically just, each pod can have its own volume, and it will handle all of the replication of the data between its own nodes. So this really simplifies running Vault highly available. There is some recommendations from HashiCorp to run it with at least 5 replicas if using this Raft backend distributed across at least 3 availability zones, which will give you like true high availability, where you could lose like an entire zone, which will be 2 replicas, but your cluster will still have quorum. It will still be able to do leader election. You'll still be up. If you run with, for example, 3 replicas and you lose 1 AZ, which takes 1 of your replicas away, and you're left with 2, the cluster will still be able to recover when the 3rd one comes back. You are not guaranteed to lose access during that time, but it is more of a chance that the leader election will fail and the cluster won't be available during that, and you'll have downtime. So that's where the 5th or the 5 replicas comes into play. Jump forward. Then again, like really high level, but so then the authentication methods that available to Vault. So when you have, we can't see that slide. Can you push? Yeah. So yep. So when you have a platform that has secrets and you need your applications and systems and all the different bits and pieces, your developers and your operators and everyone to be able to access the system without distributing more credentials and having more secret sprawl and without having to have tokens and various things passed around. What we sort of try and strive for is to have like passwordless authentication everywhere. So what is really one of the big features of Vault is these authentication methods that it supports, especially for the system to Vault or system to system type communication. So some of the ones that we use very heavily and are the big sort of like selling points for Vault, in our opinion, is this Kubernetes authentication, for example, where applications and pods basically running in Kubernetes already have like a service account attached to them. They live in a namespace, and you can grant these things access to secrets and different components inside Vault based on their Kubernetes identity without having to have a token generated and a static token, I mean. So they have tokens that are automatically generated and provided by the Kubernetes authentication mechanism. Another one that I really like is the GitLab and GitHub authentication mechanism for Vault, where you can have your CI/CD pipelines will run and can authenticate to Vault based on your GitHub organization and repository name using OIDC and using short-lived tokens, so that all your secrets can stay in Vault and your CI/CD can basically spin up and your runners can talk to Vault, fetch the secrets they need and do the operations they need to do. Then things like the cloud authentication as well, where you can have systems running in Azure or AWS or GCP and using the native cloud identities to access your Vault. Then for the developer or human operators, such things, in this day and age, you'll find that a lot of enterprise strives for single sign-on. We don't want an extra set of credentials to access anything. One set of credentials should be sufficient for accessing everything. So Vault has very good support for things like LDAP and SAML and single sign-on. And if you don't have any sort of identity provider, then you can also do username and password authentication if necessary. But being able to do single sign-on and credential-less access for your systems is like the big thing. Next slide. So then once we're authenticated to Vault, we're logged in, our applications are logged in. Then there's the concept of authorization. So what can this application access? What can this developer access with this, maybe this operator? What can he, where can he create secrets or change secrets, for example? So authorization inside Vault is built on top of the concept of Vault policies. So if you've ever worked with any other HashiCorp products, such as Terraform or Console, you'll find that there's a common HashiCorp configuration language that they've developed over the years, which is the same language or configuration language that Vault uses to define policies. which means that it's very simple and actually very effective to do all of your Vault configuration via code and via infrastructure as code, or even GitOps. So rather than having someone go to the Vault user interface and craft policies via the UI, which is possible, but one of the strong points that we use is to be able to also do all of that Vault internals via a pipeline of some sort, or GitOps, or for example, a Terraform pipeline, or there's a project out there from Red Hat called the Vault Configuration Operator, which exposes a lot of the Vault APIs as custom resources in your cluster, so you can configure, not only deploy Vault via the Helm chart, but then also configure all of the Vault internals via Kubernetes native resources. Or there is obviously, so Vault has a very good API. Everything to be done in Vault can be done via its API, and so you may find yourself building your own custom tooling to do a lot of the configuration, which is what we've done with our multi-tenant operator, which extends basically our tenant concept of a tenant inside the OpenShift cluster to also be multi-tenant inside Vault, and configures all of the paths and the policies and things for our customers and things inside Vault using the API. So there's a bunch of different options. There is a lot of configuration that can be done inside Vault, and the important takeaway there is to think about doing it as code as much as possible. So when it comes to security best practices with Vault, there's basically when we do platform and systems engineering, security is often a really matter of finding a balance between cost and efficiency and effectiveness. As I said, you can over secure things, or you can under secure things, and it's really important to try and find a balance, and to use it depends on sort of like what your needs are as a business, what your appetite is for breach basically, and what sort of data you are storing in Vault. If you go through the production hardening checklist that HashiCorp provides, there's a lot of good content there, but you'll need to sort of weigh up the cost, operational cost, as well as actual monetary cost of implementing some of these things versus like the risk. Some of the sort of no-brainer stuff that we think is worth like mentioning is it's really easy to do like TLS end-to-end with Vault, using the Helm chart and using Cert Manager, for example, to generate and manage your certificates, so that you actually have TLS pass through your load balancers and not be terminated at your load balancers and be plain text inside your cluster or inside your infrastructure. If you're able to do it simply and easily, then it's worth doing. Another point is like to avoid exposing Vault to the internet as much as possible. If you are going to expose it, then at least enforce multi-factor authentication. Try and keep it inside your private network if possible. There's different ways of doing that, and that'll depend on how you access things, if you have VPN available and whatnot. But the other point there is to like persist the audit logs. You never know when you'll need them. It's simple and easy to do. So if you've got storage to put those logs, then do it. And then there's this concept of the root token and the recovery keys, that when you bring Vault up and initialize it, these are generated. The strong recommendation there is to secure those, make them non-accessible, at least, except only for in a break glass scenario. So you shouldn't be distributing the root token between your operators, or your operations or SRE team, for example, shouldn't be using root token to log into Vault. You should, when Vault comes up, it's part of the bootstrapping is to configure a proper authentication mechanism that may have full root privileges, but is not this static root token, so that you still have the ability to base that administrative access on an IDP of some sort, and be able to revoke access and grant and add, remove people from being able to access. And then when you're running Vault on Kubernetes, it's wise to follow all of the common Kubernetes best practices when it comes keeping it namespaced and having strong RBAC on your namespaces, not running it as root, and these common Kubernetes things, which are a much bigger topic than I think we have time for today. But one example that from the hardening checklist that I think is like debatable would be where HashiCorp strongly recommends that when you run Vault in Kubernetes, that you dedicate one node to one pod, one Vault pod. And so depending on your budget, this may be difficult to do. If you're running a 5-node Vault cluster, can you afford to run 5 dedicated Kubernetes nodes for this cluster? In some cases, it may make sense. If you run multi-tenant Kubernetes clusters and have untrusted workloads running in your clusters, then this sort of consideration should be taken into account. But if your trust boundary is your cluster and everyone operating in your cluster are same organization, similar teams, then you may decide against those sort of recommendations. So the point is to be familiar with the production hardening checklist, but you don't necessarily, you'll find you won't necessarily follow it as a Bible, but need to use some common sense and risk assessment to determine what's important. Yeah, go next.
Yeah, Callum, running short on time also.
Yeah, sorry, going fast.
No, go ahead, do it. Yeah, we have time.
Yeah, and just quickly, backup and recovery. So it's actually much easier than you would think to back up Vault when running it in Kubernetes using the Raft backend. The Helm chart doesn't support it. Enterprise Vault, I believe, has backup mechanisms built in, but we run the OpenShift, the open source version, and so we basically just extend the chart with the cron job using Kubernetes functionality, basically to run a pod alongside Vault on a schedule that will just use the Vault CLI to take a snapshot, create a backup, and then write that backup to some S3 compatible storage, whether it's Minio or S3 itself or one of the other cloud providers. Then once you've got these snapshots created on a regular basis, then if disaster strikes and you need to restore your Vault from a backup, then it's just a matter of running the CLI to do the restore. Vault will then come up in a sealed state, and your auto unseal mechanism will then kick in and unseal it, and you're back to operations. Test that procedure, have it running, have it automated, and have that procedure tested regularly. But it is quite a simple thing. And at a really high, fast overview, that's some of our, from an infrastructure, I guess, perspective.
Yeah, I think backup is always good as long as you have tested it, otherwise it's of no use. Good. Guys, I think we are trying to speed up a bit, but we have one more little poll actually, which you guys can answer, please. Just like quickly. I think you don't need to spend too much time, but yeah, I think if all of you can answer, that will really help, to know how you guys think about Vault. That yeah, Sunny, I think we can just, I hope everyone has done it by now. Should we, yeah, I think, can you, Sunny, move over? Yeah, I think, can you see my screen again, Callum?
Yeah.
Awesome. So guys, I think now I'm going to move on to the day N. We have 15 minutes left. I think I will try to fast forward this, me and Callum, and then maybe we can have at least a few minutes for question and answer, so we can finish on time and don't go beyond our committed time frame. So day N, I think, so once you have Vault up and running, so let's say you decided we're going to use Vault, and then you spend time, okay, now Vault is up and running. Now the next question comes, okay, how do we start, how do we make it consumable by our different teams or tenants or business units? How do we do that, And then we talk about how you onboard applications or environments, and then how do you actually consume those secrets inside the applications. And then we like to have a quick demo, end-to-end demo. I think the first thing you have to think about is like tenants onboarding, how can you onboard tenants onto a Vault cluster, because, and since Vault has so many configuration options that it's you can choose the way you like, So what we are suggesting here is more like an opinionated way how we have done that, and it works out pretty nicely, But again, it depends on your organization size and everything around that. And if you are using the open source vault, then you of course, since we mentioned it has very solid rich ACLs, which means you have sky as the limit of how you want to configure different paths inside vault and grant permissions to the producers and the consumers. So you can do a lot of work there, actually, that how you want to configure vault. And that's actually one of the challenges that we have seen in reality, that it's a challenge that you have to figure out how to do it. So we will share some of our learnings that we have so far. And if you go with HashiCorp, I think Enterprise Vault, they have something called namespace. I haven't used it myself, but they have some namespace feature in the enterprise version. Kellan, you want to add something on this point, or should I move on?
No, let's push on. Yeah.
Good. So then I think there are basically two models that how you can structure things inside Vault. One is more like called the secret consumer based model, because you have a secret consumer and you have a secret producer, and you guys can think about, okay, which model are we going to use in order for to put secrets in the Vault? Are we going to go follow the secret consumer model? And what does it mean? The secret consumer model means that each application gets its own segregated place or space inside the Vault, And when I show the demo, and I will show you a demo, this is the one we're going to actually have in place, where we have each consumer like have its own space in Vault. It does simplify the policy writing and maintenance, because the consumer will have access to its own namespace or specific templated path, which is kind of nice. And it's kind of, the external system will write one or more secrets, but I think it does bring up some challenges as well, because if you have same API token that you would like to be that's going to be used by multiple applications, then it means the secret producer has to write it onto multiple places, like for each consumer enclave. But as I said, that's like, this is one of the common models that you can see, out there. And then the other, the second option is what's called, is the producer model, and this model is basically that each producer, will have its own segregated space inside the Vault, like a specific or templated path, And so the external system configures a secret engine and decides the access level to be allowed to the consumers. And this is a bit complex for the consumers, but because now they need to have access on different paths inside the Vault, But again, this is another model you can configure your Vault access, that you can have either paths inside Vault to be based on consumers or to be based on the
like the producer can be, for example, the team or like the operations team may be responsible for getting the API tokens from the third parties and putting them into Vault. And so in that concept, then maybe they have like a shared location where multiple applications need to fetch these, and then configuring the auth for that shared location becomes that much more complex. Yeah. Whereas if they were to have a path per application, then it's very simple that one application has access to that one secret section.
Yeah. Callum, yeah. I think there's a question. You want to take a look on that question? Oh, I don't see it, but yeah. I think Sania sent it, but I don't know. I don't see it here, but
carry on and I'll try and find it.
Good, yeah. So I think then next question comes, okay, how to consume the secrets, So let's say the secrets is now in the Vault. You have decided the structure, you have put the secret in the Vault. How do you get the secret to the application? Because that's the key thing now. And there are three different patterns or options that are available. One is called Kubernetes Sidecar secrets. The other is Kubernetes integration with apps, and the third is external secrets operator. Callum, you want to take the question first?
Yeah, so the question was like, do we have any more advice for making Vault deployment more GitOps like? Now we deploy manually via Helm. So first of all, to make it more GitOps like, you need to use some sort of GitOps engine. We use Argo CD quite heavily. It could be Flux, it could be one of the other GitOps projects. It could even be a pipeline running some shellcode. But the point with GitOps is that when you make a commit, that something happens to make that commit become live in your cluster. So when using the Helm chart, so I'll just base it basically off the way we do it. So we have a repository that has CI/CD or CI at least wrapping this upstream Helm chart and extending it. So we basically build a new Helm chart from the HashiCorp official chart, adding additional manifests to the chart and additional containers to do the initialization, to do the backup, to do the certificate generation. So adding additional manifests to the upstream chart and building a new Helm chart from that. And then that Helm chart is deployed via our Argo CD to our cluster.
I lost your voice, Callum. Do you hear me?
Am I muted?
No, you're better. Yeah, I can hear now. Yeah.
Was I talking without any sound that whole time?
No, you were talking about, I think it's like some like a few seconds, I would say. Yeah.
Okay, I'm not sure what happened. Yeah, so I'm not sure how much you've missed, but the point is to wrap the upstream chart with the functionality and build a new chart, and then deploy that new chart via your GitOps that does these manual steps. Basically, you should be able to get much closer to like a zero-touch GitOps deployment. Hopefully, you got everything that I was saying there. But let's push on.
Good. I think we can move on. Now we are running out of time. Only 7 minutes left. But okay, so Kubernetes side, like the methods, you know. Yeah. So I think Kubernetes sidecars methods. So this is like, Callum, you want to briefly go through? I will take a demo.
Yeah, so there's a few different ways that applications can interact with the Vault. One is to use this Kubernetes sidecar injection where you annotate your application to say that it does need to basically access Vault, and there's a little thing that runs in the cluster that will add a sidecar to your application, which will go out to Vault, fetch the secrets, and store them in on a file system path inside the app. The other way you can do it is with this native integration, so you can actually bake the code into your application code that will go out to Vault and fetch the secrets, which is not so difficult these days because the authentication can be handled by Kubernetes, but you still need to build that Vault logic into your applications. The third way, which is,
and there are a lot of libraries already available, you know, like
yeah,
for Golang, Python, Java, so it's possible for Spring as well.
Yeah. And then there's this another operator that we like to deploy alongside things called the external secret operator, which basically exposes a custom resource so that in your Helm chart for your applications, for example, you can also define an external secret resource, and the external secrets operator will go out to Vault, fetch the secret that you need, and it'll generate a Kubernetes secret inside the namespace for the application to consume as a native secret. And this is kind of like I'd say the simplest. It doesn't require any sort of change to your applications and anything, and I think that's the one that we're going to demo briefly today. We have time.
Awesome. So I think this is good. Thanks, Callum. So I think, guys, now I'll move on to do a quick demo for you guys. But meanwhile, if you guys have questions, feel free to shoot them in there. So basically, let me go and open up I have this. We have this prepared this demo actually, and what I have is, let me open up the console. So I have this little application that is deployed in the cluster, and here you can see this application. You see my screen, right, Callum? Right?
Yeah.
Good. So here's a simple application that's deployed on the cluster, and we have a very secret, and the secret is title of the of this this page that we are reading from Vault secret. And so let me open up the Vault first, and I will show you a demo, and then we can walk through how it is being working behind the scene. So as I mentioned before, in Vault, everything is path based, and here you can see that I belong to a tenant which is called webinar, and for that tenant, with that our tenant operator, we automatically get a path inside the Vault, and that is for webinar because I don't see other paths here. So if I have other tenants, they're using the same cluster, I won't see their paths in Vault, So we have implemented the multi-tenancy here. And if I go here in that path, we are following what is called the consumer-based model, which means I have two applications that my tenant is building. One is called Webinar API, another is called Webinar UI. So, and I have defined my paths here for them. If I go here, then I have defined different environments for my application, like dev environment, prod, and stage environment. And basically in this dev environment is what I have this secret, because this is my dev environment running right now. It says dev. So let's go and change this, this secret. Let's say create a new version for here, and we can say like, let's call it demo webinar live. And then let's, save this value. And what I'm expecting now is that I should, my pods will auto restart, in a moment actually. That you see now it is restarting already because I changed the secret inside Vault, and now I have the
external secrets operator synchronize that secret is important.
Yeah, it did. Yeah, so external secret will synchronize that secret, and then reloader will actually reload this application. Now I go here, and if I try to reload, I should get the new value from this, from the, oh, it's not still live. Come on, come on. Yeah, the demo, I think it's gonna be the Redness Pro, but should be here soon actually. Okay, sign, awesome. So basically I changed the secret in the Vault, and now it has, now my application has reloaded and I get the new value of the secret here actually. And what is happening behind the scene is good for you to know, like, okay, this is a lot of like things happening behind the scene, but in the end, or like the smallest things, I think is like this, I would say. So in a Vault, I changed the secret, external secrets operator actually reconciled, and it's okay, you have updated the secret. It actually updated the Kubernetes secret. Then the reloader, which is an open source application from Stackator, it actually watches for the change in the secrets, and it actually bumped and restarted the application, so that you got a new secret. An application was restarted automatically without just by modifying the secret in the Vault actually. I know I rushed through it, but the time was running out.
Yeah, there's a lot more. there's a whole lot more that could be talked about there.
And I think just quickly on it, maybe we should have, if you have any questions, guys, please feel free to ask. Do you have more questions? Or you can also, we can unmute you if you want to, if you raise a hand, we can unmute you if you want to have a discussion. But I think maybe some of the quick learnings, Callum, you want to briefly walk through people, or should I? I can do it, I like it. So I think, I mean, if you look at Vault, it's definitely the most powerful and tough and configurable option available out in the market. But then the question, you have to be careful and see, okay, do you really need all of those, like features or not? I think it's important. Secondly, we think that
there's operational cost. That's, I think, a big point, that the SaaS products take away some of that operational cost to a certain extent.
Exactly. And then I think the open source Vault is definitely attractive to get started, but to get a really modest production deployment, it does need quite a bit of significant effort to build and deploy. And I think it's more like, again, as I mentioned, like once you have Vault up and running, it's very important that how do you actually configure stuff in Vault, how do you create the paths and how do you do everything each time. It's a challenge, but there are like strategies available that you can follow. And the last thing is like, if you're doing local development, what should you do with Vault? You should have your own path, or should you not use Vault for local development? But yeah, people
follow your cluster locally.
Yeah, or deploy. So I think you have to be careful with those things. Good. Time for question and answers, if you have any, unless you're happy. But you can also raise hand if you would like to speak. Did someone speak? No, but I don't see any more questions popping up. Do you see, Sunny, any more questions?
I cannot see any more raised hands or any more questions either. You can still
Okay, and then okay, this is the last
questions
poll.
once
Oh, yeah,
more,
this is the last
but
poll
no.
actually. Yeah. So this is the last poll before you guys can go. Yeah. So just please answer it briefly.
Yeah, so I think like this is a topic that we like to speak about, and I'm more than happy to speak about. And if you want to speak more about it, then feel free to answer yes here, and we'll reach out and we can talk. So don't be shy.
Good. Yeah. Okay. Awesome. Then I think you can stop it. Perfect. Yeah. I think then thank you very much today for everyone for listening us. And if you have any questions, then think feel free to reach out to us.
Yeah.
Thank you very much for today. Thank you. Bye bye.